Good. All right. So I noticed Andrew Giss's talk last week that looking at this 2016 extreme loss was one of the COSMA projects ongoing. So I thought I'd better do something with it. So these are what I'm going to show is some basically some initial results looking at the 10th of the degree model to see how well this sea ice loss event is replicated in the model. So for those of you who don't know anything about Antarctica, basically since the 1970s, there has been an ongoing steady increase in sea ice. Can everyone see my cursor, by the way? Give me a thumbs up, somebody.
Yes.
Yep, great, thank you. So in a steady increase from the late 70s to 2014, and then this very sudden drop, the lowest ever recorded sea ice cover in the summer of 2016. And you can see that very clearly in this plot from Claire Parkinson's paper. If you look at the spatial distribution, obviously that's an interesting event on its own, just from the question of the variability, but also it had broader implications for the ecosystem, and also the opening of this Weddell or Mordreis-Polynya region here, which is associated with deep convection and deep ocean ventilation, and is related to the question that Andy was just asking about. This is a problem in models. So because of that, because of that event, there's been quite a bit of analysis on the drivers of this. To date, there's been, to my count, 7 papers. And most of those papers, not exclusively, but most of them consider the atmospheric drivers of this event. Partly, although Jerry Meal's paper, I think last suggested that the ocean might be involved, but it wasn't a fait accompli by any means. So one of the issues we have is that the observations are incomplete. We don't have sea ice thickness. We don't have great under ice ocean observations. So this lends itself to a model analysis. So there's a couple of outstanding questions that the OBS probably don't help with. So is there a corresponding reduction in sea ice volume? So the satellite tells us that big change in sea ice area, but we don't know how much of that represents a melt or just ice piling up near the coast. We need sea ice thickness to answer that, and we don't have it, but we can do that in a model. And then obviously as an oceanographer, the second question, did the ocean play a role either as a precursor or during the event itself? I put in brackets significant because obviously sea ice is part of the ocean, it's frozen seawater, but how important was that ocean sea ice feedback for this particular event? So what I'm going to show here today are just some initial results, basically showing how well the model does at reproducing this event. And so hopefully some teaser results, maybe to stimulate some more discussion and collaboration. So I think it's really useful to look at the timeline of this event in more detail. So I'm looking here at daily data, total sea ice area, and the time derivative of sea ice area, which I think is really useful. The climatology is in black with 2 standard deviations. The observed event is in the red line and the model in magenta, and I'm using the 10th of the degree JR55 here. And you can see this timeline is actually represented not by anything weird in the summer, which is when the anomalies are greatest, but these 2 big loss events. One in late August, early September, and this is at a time you'd expect the sea ice to be sort of still growing, not very much, more or less stable, still growing. And both the observations and the model capture this event right here. And then the rate of sea ice loss goes down to sort of climatology. And then there's this second loss event in the observations in late October, early November. But the model doesn't capture that at all. So that's interesting. So I'd argue that most of what happened is related to this event and to a lesser extent this event. And subsequent issues, it's just really tracking climatological sea ice melt. When we look at the atmospheric indices, a lot of the early papers talk about the role of this very negative SAM that happened that summer. But actually looking at these lines represent these two events. You can see that the SAM follows this initial melt. And in fact, the SAM was in a positive phase when this happened. I'm somewhat dubious that the SAM was a significant driver to this, I'll be honest. But if we look at zonal wave 3, zonal wave 3 is basically an atmospheric mode, and you'll see it more clearly in the next plot. But it basically, when zonal wave 3 is in a strong positive phase, like it was at this time, you get this pattern of meridional airflow over the sea ice. So let's have a look at the spatial distribution with reference to these sort of 2-3 week events. Okay, so I'm going to look at the average over this initial loss period, that October-November loss period. The top row shows the sea ice concentration anomalies for those periods. The OBS on the left, the model on the right, and then this is the time derivative of sea ice concentration, again as anomalies with respect to climatology. So you can see that for that initial loss period, the model largely captures the observations really quite well. There is this weird hole in the model, sort of south of Tasmania in the Mertz region, that the OBS don't have. But actually, if we look at the time derivative, that doesn't pop up. So whatever that is happened before, is in the model before this 2016 event. It's some kind of residual. But other than that, it looks pretty good. The melt regions at the edge are a little more intense in the model and a little more organized, but I think you'd expect that given the sort of relatively coarse resolution of the JRA product. I do wonder if the Weddell gyre has a role in that, but I'm happy to discuss that further. So that's captured pretty well by the model. I'm happy with that. For this October-November period, you can really see that zonal wave 3 pattern. So if you imagine atmospheric circulations, you know, bringing warm air and pushing the ice in the red regions and pushing the ice out in the blue, and then you have 3 of them. So you can really see that zonal wave 3 pattern. And it's also evident in the melt and growth rates. Now, what's really interesting, and I've heard Matt England ask this question, is that if zonal wave 3 is involved, you get these regions of melt, but why not corresponding growth? Well, actually in the model you do, Matt. And that's why this doesn't pop up in the model in the overall total sea ice extent. You get regions of melt that are at least as strong as observed, but they're counteracted by growth, which we don't observe. So I think that's a really interesting difference, and it might tell us something about this event. But in summary, I think the spatial distribution is well captured by the model in terms of the response to the atmospheric driver, but there's something weird going on here. So I'm pretty happy so far with that, although obviously there are some more questions. And then my other question is whether it's worth considering looking at in terms of whether there is really an ocean role to play in this. So I'm expanding the time scale now to 2012. That's somewhat arbitrary, don't ask me why, it's just what I had available. So this is ocean heat content in the upper 100 meters by longitude and month. And these lines here show that 2016 event. Now you can see when you look at the plots of sea ice area anomaly over the same period, again it's longitude, you can see a really close match between those regions of loss and warm ocean anomalies. And you actually get a cold anomaly here, right here, which is where the difference between the model and the OBS is on that later event. So it's well matched, but what's really interesting is that whatever this is, it starts in the middle of 2015. It starts a year before that 2016 event. And in fact, if we look at the time series of total sea ice extent, again, black is the OBS, magenta is the model, you get this peak up in 2014, and then this precipitous decline. So this is 2016, but actually 2015, although it doesn't know temperature, because it was bang on the climatology, it actually, I think, is a continuum of this decline rate here. So what's ever happening, I don't think is a 2016 event. I think it's a 2015 event that just shows up. So then the next question is whether these ocean heat content anomalies, are they related to, are they a result of the loss of sea ice in this region? Because you get less sea ice cover, so more heat uptake, or are they a driver of that? Now, I don't yet have a good answer to that, and I'm sure we're running out of time, but I want to have a look at this. I think there's really interesting results here. So this here is the ocean temperature anomalies by depth over the whole sea ice zone and salinity. So you can imagine you have this increasing growth of sea ice, so a layer at the surface that is cold and fresh that we know is related to, we expect to see that from an increase in sea ice cover. And then in this 2015 winter, bang, you get this pulse of cold and salty water, which I suspect is probably winter water. It's the cold, salty water that's formed as a result of sea ice growth. And it entrains right into this warmer, modified circumpolar deep water layer. Then you get a summer melt, and that puts a cap on the surface and prevents upwelling of this cold water, although we're not actually seeing it in the salinity, so I'm not quite sure what's happening. But then during the next winter, just before that loss of sea ice, this water, this warm water, finally makes it up to the surface. So obviously that's very preliminary, and there's a lot of hand waving and speculation there. But there's definitely enough, I think, in the model for us to explore further that whatever happened here happened in the winter of 2015 and is related to the entrainment of warm water up to the surface. So I don't know how we're doing for time, but just to give you a summary. So that 2016 event, I think, was two kind of phases: an initial extreme loss in late August, early September, that's pretty well replicated by the model. And then a second 2-week loss in October, early November, that's spatially reasonably well replicated, but the model gives offsetting regions of sea ice advance that didn't happen in reality, and we're not sure why. And I think that 2016 event actually might be a 2015 event, and something related to ocean sea ice feedback. So obviously there's a lot more still to do, and I'm really happy to open up a discussion with other people who'd like to be involved with this work.